Okay, this is a homework help for Math 3 Unit 2 Worksheet 4. So 1 through 16 we're just factoring, so I'm going to do number 10. So let's start with number 10. Okay, so the first thing I want to do is try to figure out what are my factors for the first and last term. So I know 2x squared when I multiply is 2x and x, and that's the only way to get 2x squared. And then for 5, the only factors for 5 are 1 times 5. And so I know when I set this up for factoring, my x terms go in the front. And now I just have to figure out, like, where should the 5 go, where should the 1 go? So just for mental math sake, if I do multiply these two together, I get 2x. And when I multiply those two together, I get 5x. So 2x and 5x will give me the 7x. So if I want the 2x to multiply to the 1 has to go over here, right? Because we multiply across parentheses, so 2x times 1. And the same with the 5 over here. Okay, so if I flipped it, I wouldn't get that, right? And so if I did it the other way, where I did 2x times 5, I would get 10x, which already is too much because I'm trying to get 7x. And then I do want to do a quick check always, so multiply these two together and multiply those two together, and 5x and 2x does add up to 7x, right? So then I know my factors are correct, and so that would be my answer. Okay, let's check out number 15. So same idea, so the only way to get 3x squared is 3x times x. To get 4, 1 goes into 4, but so does 2. So it could be 1 and 4 or 2 and 2. And so I know it has to be 3x and x. And then from here, I want to figure out what pairs will give me 8 somehow. And so if I look here, multiply 3x times 1 is 3x. And then multiply these two together, that is 4x. So 3x and 4x is only 7, so that won't work. And if I flip-flop, 3 times 4 is 12, so I have 12 and 1, so 12 and 1 won't make an 8. So I know it can't be 1 and 4, it has to be 2 and 2. So because they're the same, it doesn't matter which 2 goes where. And then this will give me 6 and 2, so 6 and 2 will give me 8, but I need it to be a negative 8, so I need both to be negative, which has to work, right, because I need to get a positive 4 when I multiply. And then do a quick check, so that's negative 2x. And then negative 6, and then that equals negative 8, so I know I did that right. Okay, so make sure that you're paying attention to the directions. So when it says to factor, then our answers need to be left in parentheses, right? When it says to factor, we leave our answers in parentheses. Okay, the next section is telling us to solve by factoring. So that means after we're done factoring, we go another step further and we solve each factor for x. Okay, so I'm going to take a look at question number 20 here. So I want to solve by factoring. So I need it to be equal to 0, and I need to distribute. So if there's terms to combine, I can. So I'm going to multiply x into both of those. So x times 3x. And x times negative 1, and then equals 4. So I need to make this equal to 0, so I'm going to subtract 4 over to the other side. And then now I'm going to do my factors. So for 3x squared, the only way to get that is 3x and x. And then the only way to get 4 is 1 and 4, or 2 and 2. And now I have to find the combination that will somehow give me a 1 when I add or subtract my values. So if I look here, 3x times 1 is 3x, and then x times 4 is 4x. So I would have 3x and 4x, and if I subtract those, that will give me my 1x. So I want to do 3x times 1, so 3x and the 1 need to be in different parentheses. And I want to do x and 4. Now I want to get a negative 1x, right? So this would give me 4x, and then that gives me 3x, and the only way to make that a negative 1x is if the 4 was negative. So negative 4 times x is negative 4x, and 3 times 1 is positive 3, so that gives me negative 1x. So now once it's factored, I'm not done, right? I actually have to solve this equation. So now by the zero product property, I'm going to take each equation and equal them to 0. So I'm going to do that on to the side over here. So I would have 3x minus 4 equals 0, and then x plus 1 equals 0. And then solve each of those equations. So I would add 4, and then divide by 3. And then over here, I'm going to solve for x, so I'm going to subtract 1. So then x equals negative 1. So x is 4/3 and x is negative 1. Okay. And then let's take a look at question number 24. So I want to solve for x, so I'm going to subtract 10x because I need it to equal 0 before I can factor. So I'm going to subtract 10x. So then I'm just going to write those side by side and then equal it to 0. And then this is not a trinomial, so I need to look to see is there something common that can be factored out of both. And I know I can divide a 5 out of both of those, and they also have an x common. So I'm going to divide out my 5 and my x, and when I do that I'm left with 1x there, and then negative 2 here. And then as soon as it's factored, I'm using the zero product property, so I'm going to set each equation equal to 0. And then solve. So here I will divide both sides by 5, and then 0 divided by 5 is 0, and then add 2 to both sides, and so x is equal to 2. Okay. Right, and then the back side. Okay, so for this section, we're doing a different method to solve, not by factoring, but we're going to solve by using square roots. So solve by using square roots. So I'm going to take a look at number 32. So the first step is we want to isolate the squared term. So I want to get the squared term by itself. So I don't want to add the 1 and the 3 together because they're not being added, because 3 is multiplying, right? 3 is multiplying, order of operations. So that means I need to subtract the 1. And then divide by 3. And then once I get to here, so this squared term is isolated, I want to square root to get rid of the squared. The square root of something squared is the absolute value, and then the square root of 4 is 2. And then once I get to here, this is just like solving like we did in objective 2. So I have an absolute value, and now I'm going to use the method from objective 2. So I determine the number of solutions. It's equal to a positive, so 2 solutions, 2 equations. So my first equation is the way I see it, the positive version equal to 2. And then the other is the negative version equal to 2. So then solve, so I'm going to subtract 4. And then here, I'm going to divide by negative 1. And then subtract 4. And negative 2 minus 4 is negative 6. Okay, so my solutions are x equals negative 2 and negative 6. Okay, and for the last group here, let's take a look at simplifying. So this is front-loading quadratic formula and how we simplified using quadratic formula. So kind of a little bit of a review from last year. So let's take a look at number 36. So because of order of operations, we always want to do it inside our grouping. So inside our grouping is our square root. So I have a 9 here. And I want to do exponents first, so negative 9 times negative 9 is positive 81. And then I can multiply these values together here. So 4 times 1 times 4 is 16. And then 2 times 1 is 2. So I'm still not done simplifying this portion right here. So I need to subtract. So I'm going to do 81 minus 16. So that would be 65. And then divided by 2. And then I want to know, is there any perfect square that divides into 65? And the only number I can think of that divides into 65 is 5, because it ends in a 5. So I'm just going to do some long division over here. So 65 is 5 times 13, and I don't know this don't know the square roots of either of those, so that's the most I can do to simplify. Okay. And then let's do one more. Let's take a look at number 38. So order of operations, I want to simplify inside the square root first. So I'm going to do the power first. So negative 6 times negative 6 is positive 36. And then I'm going to multiply these together. So negative 4 times 1 times negative 3 is positive 12. And then 2 times 1 is 2. Okay, and I don't want to divide these, right? Because the 2 is not just dividing 6, but it's dividing everything. So I want to keep working on doing the square root part first. So now I'm going to add 36 and 12. And then now I have to see, is there a perfect square that goes into 48? So I'm going to do that over here. So I know that's 4 times 12, and I know 12 is 4 times 3. And these are both numbers I know the square root of, right? I know the square root of those. And so then this will be 6 plus or minus 4 square root of 3 over 2, right? So 4 root 3. And so now, if I look, I can see that the 2 divides into the 6 and into the 4, so then I can reduce this. I couldn't just do 6 and 2 because it has to also divide into this number, and then that's the only way I can reduce, because this means 2 is into both. So 6 divided by 2 is 3, and 4 divided by 2 is 2, and then root 3. And that's the homework help for worksheet 4.